will be our last. All right. This will be our last class of Python 2. Um, so yeah, let's just get started. All right. So a little refresher from what we've been working on since we didn't meet last week. We were working on classes, and subclasses and inheritance and all that good stuff in Python. Um, and our homework assignment was to implement an example of subclassing. Um, so this is our example. So we have a class car, and then we have another class called Tesla that inherits from car. Um, and and for the homework, we wanted to override two methods in the superclass. And by override two methods, I mean um, I mean essentially having a method that has the same name as the original method in the superclass. So so for example, in our Tesla class, we have a method called RevEngine that is also a method in the superclass for car that also has RevEngine. So so the rev engines in car and in Tesla does two different things, even though they're named the same thing. So that is an example of method overriding in object-oriented programming. Um, let's see. Uh, so yeah, I mostly wrapped up our talk of classes in our last class, so I won't spend too much time on this so that we can move on. So I will post this code so that you guys can have it as reference and you can take a look at it in case you ever need to do any object-oriented stuff on your own. So I will post this. All right, posted. So now we will continue on to what we were working on last class, which was iterators. Or at least we didn't start with iterators. So from last class, we were talking about variable scope. So Audrey or Ava, can one of you in your own words tell me what variable scope means? Yeah, I'll explain. So variable scope is essentially um, it's it's how it essentially entails the the block of code in which a variable has access to. Um, So variables can have global scope or local scope. So local scope means that a variable can't be called or can't be used everywhere. But if a variable has global scope, that means it can be used anywhere. So that's essentially what variable scope means. Anyway, we have iterators. So what is an iterator? We learned about loops and we understand that it provides a way to loop through every item in a collection. Now we want to learn a similar mechanism in Python called the iterator. An iterator is an object that can be iterated upon, meaning that you can traverse through it, meaning that you can traverse through all the values. Strings, lists, tuples, dictionaries, and sets are all iterable objects. They are iterable containers which you can get an iterator from. All these objects have an iter method, which is used to get an iterator. So let's spend 5 minutes on this Geeks for Geeks website. I want you guys to think of iterators as kind of like um, a generalization of loops. Uh, okay. So according to Geeks for Geeks, an iterator in Python is an object that can be used to iterate over iterable objects like lists, tuples, dicts, and sets. So we know that we can iterate through lists and dictionaries and stuff. Um, so in Python, iterator objects are initialized using the iter method, and it uses the next method for iteration. Um, so yeah, and then it provides an example here. So we have a string GFG, and then we declare our own iterator, iter string, and then we kind of manually do our looping with the next method. Um, so the two methods that you guys need to remember when it comes to iter is 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 underscore iter. Well, I mean, it doesn't really even have to be underscore, but just remember iter and next. And what iter does is that it initializes the iteration, and the next is what actually does the next value. So those are two important methods to remember. Anyway, let's go back to our lecture. As we did before, we can use a for loop to iterate through an iterable object. The for loop actually creates an iterator object and executes the next method for each loop. So we have an example of that here. We all know how for loops work. So we have a string, banana, and then we have for x in my string, print x. This is an example of just a regular old Python loop. So under the hood, what this for loop is doing is that it's calling two methods, the iter method for initialization and the next for actually doing the looping, and the next method for doing the actual looping. I think we'll see an example of that in the next slide, maybe. Uh, so to make sure that we're paying attention, what are the two main methods when it comes to iterator objects? Can anyone tell me that? Iter and next. Good job, Audrey. So technically in Python, an iterator is an object which implements the iterator protocol, which consists of the methods iter, which returns itself and next. To prevent the iteration from going on forever, we use the stop iteration statement to terminate it. Now let's build one iterator since we know how to build a class. Oh boy, okay. All right, let's break this down. Um, so we have a pi series class. Can anyone tell me what class that pi series inherits from? What's the name of the class that pi series inherits from? Object. Very good, Audrey. Very good. It inherits from objects. Um, and the attributes of pi series is current and high, and we're setting current and high to low and high. And that's what the the programmer is passing into pi series. Um, so here we've defined what iter does. It just returns self, and we've defined what next does. So what next does is that if self dot current is greater than self dot high, then stop iteration. Else we increment current by one, and then we return self current minus one. That's interesting. Okay, so if we run this next endless. Okay. Okay, so in our output, we're getting one, two, and then a list of numbers. Um, so we get this because we're declaring a variable n list, which is a pi series object from 1 to 10. And then see how we're kind of manually doing our looping with next. We do next n list to increment um, our current variable, self.current by 1. And then we do it again, and then it becomes 2. And then we have list pi series 1 comma 10. So what that does is that it creates this list down here, does all the iteration. Um, so one way to think about iterables is that it's kind of like creating your own for loop, but you're like describing how the looping is actually done instead of doing it by default. It's a pretty high level concept that's used in object-oriented programming sometimes when you want to define how to iterate through an object. Uh, so don't be discouraged if you guys don't understand this right off the bat. Okay, now we have an exercise. Uh, we're going to create our own letter iterator. You can pass in the start and end letters. The next method will return the letter next to the previous letter alphabetically. If the end is before the start, then next will return the letter in reverse order. It will terminate when end is reached. Okay, this one's actually pretty tricky. I'm not even sure if I could do this one right now, but we'll see. Uh, so we'll keep pi series as reference, and we will mess with this one. So we'll call our class letters, and it inherits from object. What are the instructions? You can pass in start and end letters. So since we can pass in the start and end letters, we can rename this one to start and this one to end. We can name this one start and end. So now we have two attributes for our letters class, start and end. And these will represent the letters that we're passing in. So we're eventually going to pass in, oh, yeah, about some of the instructions in the chat. Let's see. Um, all right, So here are the exercise instructions that we're working on. So we eventually will want to have a variable called foo that is a letters object that takes in, say, A to N or something like that. Um, well, actually, letter A and letter N. Uh, yes, Audrey, I see that you're unmuted. Oh, okay. So we have our iter method that will just leave the same. Um, but let's see what happens if we just were to run this as is. Um, so far we've just changed what we're passing into our class letters into characters A and characters N, and it did nothing. Okay. I wonder what happens if we do next. Oh, okay. Let's see. So according to the instructions, we want to pass in the start and end letters. Okay, we've done that. We in line 14, we have letters A to N. The next method will return the letter next to the previous letter alphabetically. If the end is before the start, then next will return the letter in reverse order. So that's what we need to do next. Um, let's figure out how to make it so that make it so that next returns the letter that's after the start, which in our case is A. Um, hmm. Yeah, sorry guys, I'm just trying to think through this myself. Um, yeah, may have to come back to a solution, because a solution later, or else we're going to be here for the rest of class probably trying to figure this out. Um, but yeah, so we've done the first part, which is to pass in two letters into our class. Now the next part is to figure out how to get the next letter from our starts. So let me do some quick Googling. Yeah, I think we'll just have to come back to this exercise, or maybe I'll post the solution to it, um, because I can't figure out this off the top of my head. Anyway, let's move on. It's been about 10 minutes now, so let's move on to the next um, slide. So the iter function creates an object which can be iterated one element at a time. The next function retrieves the next item from the iterator by calling its next method. If default is given, it is returned if the iterator is exhausted, otherwise stop iteration is raised. So this slide is just describing how the iter and next functions operate essentially. Um, so we have an example that shows how iter and next work. So we have a string, my Python code. Actually, this might be helpful for the exercise. Let me just, we have a string, my Python code, and then my it is equal to iter my string. That makes sense. And then we print next my it and next my it. And then let's run this and see what we get. Okay. So what this is essentially doing is that it's iterating through this string, my string, and my tuple, but it's doing it essentially manually. So we have my strings equal to Python code. My it is equal to iter my string. Then we print next my it, and then we print next my it. So that's why we have the P and Y here because iter is what initializes the iteration, and the what initializes the iteration variable essentially, and then next is what does the actual looping. Um, so again, just think of iter as the iter method as kind of initializing the loop, and next as doing the actual looping one by one. And we saw an example of it working for a string and also for a tuple. Are there any questions on iterators so far? I know this is kind of a dense subject, kind of hard to understand, but um, I'm trying to keep it very high level for us. Any questions? All right. So the iter function can also create an iterator from an object that has the getItem method. The getItem method simply returns an element from an object based on a numerical index. If the numerical index does not exist, it raises an index error. What does that mean? We have an example on this slide. So we have class key iter. Um, let's run this quickly and see if it gives us any errors. No. Okay. Let's see. Oh, okay. Right, that fixed the issues. Okay, so we have a class called keyIter, and it has a function called getItem that takes a key, and then we have if key is in between 0 and 3, then return key, then raise an index error. Interesting. Oh no, okay. Okay, so if the key is not between 0 and 3, then raise an index error. And then we have, and then we make a key object, and then we start iter key, and then we do next, and then, but that doesn't print anything. So if we were to put, um, let's say we put 1 in here, what would happen? Takes no arguments. I'm not really sure what this is supposed to. Okay, all right. So I think because I have more than um, two iter keys here, I gave an error. Let's see if we have only two. Okay, all right. Okay, I think I understand what's going on now. So going back to the previous slide, the iter function as a object, the iter function can also create an iterator from an object that has the getItem method, which simply returns an element from an object based on the numerical index. So because I called next a few times, the main idea to get from this piece of code is that we can use getItem as kind of like a proxy for counting the amount of times that we do next. So what this code is saying is that we're kind of keeping track of the times we call next with key. So if we call key, or if we call next more than twice, really, then it's going to give us um, an index error, or more than 3 times. Sorry. So I have it 4 times here. It'll give us a stop iteration um, because a key can be between 0 and 3. So yeah, let me just move on. So another exercise. Please create an iterator of X and use the loop to print out each character, skip space. Oh my goodness. Okay. So our goal is to create an iterator that loops through X. Let's use pi series as a reference here. What the? Okay. So let's see, we're gonna have class. Our goal is create something that iterates through X. Um, so we'll probably need getItem actually. Let's try to use getItem. Yeah, I'm not too sure how to do this off the top of my head. This is interesting. Yeah, so our goal again is to create an iterator of X, something that an iterator that goes through X and use loops to print out each every character, and we want to skip the space. Uh, Sadly, I don't have the expertise to do that right at this moment. So like the previous exercise, I'll try to figure out how to do it and then I'll post the solution. But anyway, I'm just gonna move on. Okay, this is for advanced users. Uh, Iterable is an object which one can iterate over. It generates an iterator when passed to the iter method. Iterator is an object which can be used to iterate over an iterable object using next method. Uh, and then some more stuff here. I think this slide is just kind of just review. So remember when you see iterators, just think of the iter method as what it kind of instantiates an iter object. And then next is what does the manual looping. I think the rest of these slides say the same thing pretty much. Um, and then we have a homework. This is very advanced stuff, showing has how I can even do this off the top of my head. But I'll give this a homework assignment to you guys anyway, for you guys if you feel like again having a challenge. So create a letter iterator by using get item, not using iter. You can pass in the start and the end letters. The next method will return the letter next to the previous letter alphabetically. If the end is before the start, then next will return the letter in a reverse order. It terminates when end is reached. Uh, so yeah, this one's actually pretty challenging. So I'll much kudos to you guys are able to do it. But I'll post this. Okay. Well, let's move on for this to slides for class 15. Um, so okay. Uh, Quick review, how to change the value of a global variable in a function. Um, you just mark the variable as global um, when you declare it, or at least when you pass it when you're in the function itself, you say global variable. That way you can change the value of the global variable. So I mean, adding a keyword global before the variable in the local function, that's how you get it to change the value of a global variable in a function. What is the difference between an iterable and an iterator? Um, an iterable is something that can be iterated upon, and an iterator is what does the actual looping. That's the difference. And what do you have to do to create an iterator? That's essentially asking what are the two main methods for iteration. And as Audrey has said earlier, it is iter and next. So you have to declare those two to create an iterator. To create an iterator. Any questions on that review? All right. So we learned code block, we learned functions, and we learned about classes. Usually these code blocks cannot be split. They have to stay together for an application that needs to achieve a complex goal. We need some other high level of code organizations. So this is saying that code can get pretty big. As your program gets longer, you may want to split it into several files for easier maintenance. You may also want to use a handy function that you've written in several programs without copying its definition into each program. Straightforward problem. To support this, Python has a way to put definitions in a file and use them in a script or an interactive instance of the interpreter. Such a file is called a module. When we created our first Python project, we also created a module. So this is kind of putting some context into what we learned about when we first created our IDEs and stuff. A module is a file containing Python definitions and statements. The file name is the module name with the suffix .py appended. Why? You can reuse the code and other developers can also use your code. So if we were to look at our code for a second, I have a Python script called basiccode.py. So that is an example of a module because it's a .py file. Um, yeah. If you did it, Audrey, that's great. Yeah, we can share your screen maybe towards the end of class, and we could see what you did. So anyway, modules are pretty much just Python files, right? And and we can import modules or Python files into our own Python file so that we can use the code in there for our own purposes. Some other examples of Python files include, I think I spelled class wrong here. No wonder it wasn't working. Whatever. So we can do like import math. So math is an example of a really powerful Python module. We have import pandas, another really popular Python module. Import NumPy. Actually, I wonder if these will actually run no module called pandas. Okay, so it's not here by default. You have import sys. That's another one. So math and sys are two pretty big Python modules, and we've used them in the past before, I think. And we also have a Python module that was provided to us called Fibonacci. Yep, so it's in the Google Classroom actually. So let me download this and open it. Or maybe I'll just copy it. So we have another Python module here called Fibbo for the Fibonacci sequence. Um, so we'll be using this later in the lecture. It says now copy the Fibbo file to Python folder installed. I wonder how we can get that to. I'll post it on the Google Classroom so that you guys can just open it up yourselves if you feel like it. There it is. Okay, so that's there now. Um, so now you, so now Fibo.py is on the Google Classroom. So you could open it up on your own interpreter and walk through the code. So we could import Fibo kind of like just like this, import Fibo. Yep, that works. Okay, I'll explain what I did here. So I added another Python script in my IDE called Fibo.py, and it has two methods in it. And then I went back to my other Python code, and then I imported Fibo. This way I can use the methods in or the functions in Fibo, but in a different Python script. So that is a major point of modules. So we can imagine that if we have a lot of code in Fibo, we wouldn't want to re-implement it again in my other script. So we just imported the code with this one line. Does that make sense to everybody? All right. So there's one thing though. A module must be in the path that Python knows in order to import it. Here it's in the same folder as python.exe, or in our case, it's in the same folder as my basic code.py. When a module name is imported, the interpreter first searches for a built-in module with that name. If not found, it searches for a file named .py in a list of directories given by variable sys.path. So this pretty much means that when you type in import whatever, Python first looks to see if it's a built-in module like math or sys or something. And then if it can't find it in there, then I'll search for all files with the name of the module that you were trying to find .py. That's essentially what this is doing when it's searching for a module. And so before I move on, can anyone tell me one advantage of using modules in Python? Yep, that's exactly right, Audrey. You don't have to write as much code. Very good. All right, moving on. Import sys.path. So let's import sys. Okay, so sys.path pretty much is all the places that Python will search for modules in. So what I printed out right now is my sys.path. So these are all the directories that Python will look for modules in when I do import whatever. So usually the Python library is located in the site packages folder within the Python install directory. You can also add your own path to sys with sys.path.append my custom module directory, and then you can import my custom module. So within the module's name is available as the value of the global variable underscore name. Okay. And we can also call functions in the module with the syntax, the name of the module, followed by the method that we want. So I could do something like fibo.fib100, and that does the function as described in fibo.py. So fib just prints it while fibo2 returns it. Um, this will still run. Oh, whoops, I need to do two. Okay. So let's all make sure that we know the syntax for calling a method or a function in a module. So we do the name of the module, in this case, Fibo, dot the name of the function that we want to call. So in this case, it's fib, because in our fibo.py script, we have a function called fib. So that's what we're calling when we do fib here. And of course, we could also do fibo.name, which will return the name of the module. Yep, just Fibo. If you intend to use a function often, you can assign it to a local name. So if we know that we're going to use fib often, we can say fib is equal to fibo.fib. And then we could just call fib without having to do the fibo.fib part. So this is another example. Let's see what else we have. A module can be used by other Python code if the module is imported using the keyword import, which I've shown. An imported module is not executed unless unless they are standalone statements. There is a variant of the import statement that imports names from a module directly into the importing module's symbol tab, for example. So right now we're doing import Fibo, but we can also do from Fibo imports fib and fib2. That way we can just use fib and fib2 however we want. Let's print out the same exact thing. No, well, oh, whoops. Yep, so this will do the same exact thing. So we could just use, instead of doing import, we could do from the name of the module, import the functions that we want. That's why we can like pick and choose which methods or functions that we want to import from a module. It is also possible to import all names from a module into the current namespace by using from mod name import start. So we can do from Fibo import star. This will import all the functions in the script. What else? You can create an alias when you import a module by using the keyword as. So we could do import. Oh my gosh. We could do import Fibo as Fibonacci. Then we could do Fibonacci uh, dot fib. I spelled Fibonacci wrong. Fibonacci dot fib. And that gives us the same thing. So yep, we're just playing around with a few different ways of importing modules. And then we have a quiz, a few quizzes actually, but before I get to that, I want to see what Audrey's solution is. So Audrey, I'll give you a chance to share your screen. Are you ready? You can go ahead and share your screen now, Audrey. All right, let's see what you got. Okay, so it looks like you have a variable for the exercise. X is equal to inside the iterator. Okay, good. X is equal to X dot replace. Oh, very nice. Okay, so you are getting rid of the spaces in the string. Very good. And then you iterate through the letters in X. Very good. Um, okay, let's see you run it. All right. Very good, Audrey. There is one caveat though. So to create an iterator from scratch, you'll have to use the iter method and the next method. So that would require making your own class. So you'll need a class that, well, so you'll need a class that has an iter method and also a next method. Um, that way you'll be doing it the same way that the exercises do it. So that might be some example code online that you can look at users as reference. And also this is recorded, so you'll be able to see my explanation in the beginning. But that was good though. I liked how you figured out how to replace the um the spaces in the string with just an empty quote. And you looped through it correctly as well. So very good, Audrey. You've really killed it this class. Anyway, I guess we can end this session with a quiz or two. So let's see. Quiz one, a Python module is a file with blank file extension that contains valid Python code. So our options are .py, .module, .pymodule, or .pym. Can anyone tell me what the answer is? The answer is A. Very good, Ava. So we have add is defined in a module called adder.py. Which of the following code snippets correctly shows how to import and use the add function? Select all that apply. So there are multiple correct answers here. Right, so the correct answers are A, B, and D. Wait, no, A, C, and D, sorry. A, C, and D are correct ways to import add from adder. So yeah, last quiz. Um, what will be the output of the following Python code? Hmm. This is probably going to give an error because we have two functions called change. So Python won't know which one to use. It'll either give an error or it'll just go with the one in mod 2, which will which will print B or whatever. So yep, this one should probably be an error. I don't have time to test it out though. Okay, guys, it's about 7:30 now. So yeah, thank you guys for coming to this last class. I hope you guys learned something over these past 8 weeks. Even I learned some stuff. Are there any last minute questions? All right, well then, I guess good evening then. Yep, thank you, Ava. Yep, thank you to you too as well. And then thank you to you, Audrey. You guys have been great. Um, so yeah, good luck on your endeavors. I'll probably be seeing you around at the club if you're ever there. And yeah.
Thank you so much, Mr. Osu. Yeah, it's already a great time for us to have you here. So, Ava and Audrey, yeah, if you have a question, you can ask. Otherwise, you are good to leave. Yeah. Thank you. Give me 1 second.